Yeah, so I guess we might as well just dive in, take a look at, first of all, what we did last time, and then we'll talk about how we can sort of change this, refine it. Our first goal is going to be to make it work because last time we didn't quite get there. We got a few of these right, but most of them very much not right. Okay, so we want to fix it first. Then we want to improve it, right? We maybe want to clean it up a bit. We might want to, I don't know, if we can find a way to switch it in such a way that's going to make it more efficient, that would be nice too. So yeah, I guess those are going to be kind of our priorities, and that's something I'm going to mention in my code judging guidelines that I'm going to be posting probably later tonight in terms of the round Tetris challenge that's going on. Basically, the priorities should be to make it work, make it efficient, make it beautiful. Okay, so basically that's what we're going to do. So first we need to make it work. Let's try to figure out what this is trying to do and why it's not working. Okay, so part of the reason this is so sloppy, and you're probably noticing that just by looking at it, part of the reason it's so sloppy is because we built it up one little bit at a time. So we started yesterday with something that was just going to look for the intersection of a horizontal word and a vertical word, nothing else. It was just looking for the ways that they could intersect. Now that alone took a nested loop. I mean, no surprise, we're in the labyrinth after all. We needed 2 for loops in order to really figure that out. I suppose there's probably some way we could avoid that. Like we could probably use like index of or something like that if we wanted to do that. But I mean, an index of needs to go through the entire word anyway, so it's not really going to save us any time to do that. So yeah, I don't think that would be any more efficient. Point is, we've got 2 nested for loops right off the bat. Actually, it wasn't these 2, but it was one for the horizontal word and one for the vertical word. Now we have 2 just for the horizontal word, which maybe seems a little strange, but the idea is that the horizontal word, which would be crossword in this case, it's going to join to 2 vertical words at 2 different locations, right? So it's basically I for the first one, J for the second one. And actually, that brings me to another important point. In this case, notice we've got this thing over here, if math.abs of j minus I divided, if the absolute value of the difference between j and I is less than 2, then we're too close. We're going to violate this, this principle over here. We can't have the words right next to each other. And we definitely can't have the words overlapping each other. Okay, so that's what this is all about. So basically we have these 2 for loops. Those are just deciding on the points in the horizontal word, the first horizontal word, where we're going to join up these letters, right? Then we need to figure out, okay, well, which letters will actually make that happen in each of the vertical words. So that's why we need some additional for loops, one of them for v word 1, vertical word 1, and one for vertical word 2. These are basically just going to find the points where they're actually equal, right? So we have V letter 1, V letter 2, we have H letter 1 and H letter 2. We just want to check, are they the same, right? Do we have a situation now where we actually have the same letters lining up? Now again, this is something we could probably make more efficient because we're basically going through every possibility and seeing if the exact thing we're looking for is true. Really what we should probably be doing is, even before we get into this for loop, we should be saying, well, is H letter 1 the same as V letter 1? Because if it's not, why bother checking all the possibilities for V letter 2, right? So we'll make that change in a little bit. But before we do, let's just make it work. And before we even do that, let's keep reviewing here. Let's review what happened last time. Okay, this is where things start to get a little bit complicated. So up to this point, through the use of 4 levels of nested for loops, we have found successfully the intersection of 3 words, right? So it would be, you know, something that has crossword, something that has formation, and something that has square, but it doesn't have the something. Okay, so now once we have these in place, we're basically saying, well, could this 4th word fit in somehow? And basically what we need to do is compare it to these other words, the formation and the square, and we basically just need to check, like, well, a few things actually. First of all, we need to check if it could connect at, like, you know, could it connect here? Could it connect here? Could it connect here? Could it connect here? And we also need to check, like, at what point in the word something should it be actually connecting as well. Okay, so there are a few things for us to take a look at here. But basically, that's the reason why even once we've got this far, there's still 2 more for loops that we need. Okay, so in total, we have 6 levels of for loops here. It feels a little gross, to be honest. I mean, as you guys know, my goal is usually to try to find a way to do this without nested loops. I think it's really important to sort of have an aversion to using nested loops because it can just really, really skyrocket the time complexity. You know, it can really, really get fast. Anyway, sorry, you can get slow fast. That's what I meant to say. Okay, anyway, the point is, continue with this. Why do we need these things? You know, this is maybe the first point where we're looking at this and thinking, wait a minute, what's that all about? Okay, so basically we've got the horizontal offset, we've got the vertical offset. So for these over here, this is basically the vertical offset is like notice how formation starts up here and then square starts down here. So that would mean that the H offset in this case would be 2. Or depending on which one came first, it might be -2 because notice that we're not really putting these in order. Like we're doing the 2 for loops, which are going both from 0 to the length of the first vertical word and from 0 to the length of the second vertical word, right? So we're going through, actually, sorry, it's not that one I should be focusing on. It's these ones. It's the fact that both of these go from 0 to the length of the horizontal word. So basically the idea is that I could be anything from the start to the end of crossword. And J, same exact thing. And then we're checking, oh, do they intersect? So maybe something we're going to do a little later, maybe some way that we could refine this is to actually have an order to these things and to actually say, okay, formation is going first, square is going second. And we'll find out why that might be a good idea a little later because, you know, originally I thought, well, why don't we try it this way? Maybe we could do it in fewer loops that way, but no, I was wrong. In fact, I think this is less efficient. So we'll find out exactly why in a little while, but for now, we're going to continue. So basically, we don't know which one comes first, formation or square, which means we don't really know if our H offset or V offset, if these are going to be positive or negative. The V offset is basically like in this case 2 or -2. The H offset actually would be the same in this case because it refers to this. How spaced out are these like little connections here? Now if we give ourselves a little more room and take a look at this one over here, this would be a good example to look at because in this case the V offset would be either 1 or -1, whereas the H offset would be 3 or -3. It's how far apart they are horizontally. Why do we need to know those? Well, it's important because in terms of the way something, in this case, is going to line up, it's basically going to have the same spacing between its connection points here as this one did, right? It's not like one of these words is going diagonal or something like that, so they're going straight down, so the horizontal offset has to be the same. The other thing is the vertical offset kind of has to be the same too, in the sense that, like, you know, this was the 0th character of square, but this is the one, like the first character of formation. So by the time we get down here, if this is the 0, 1, 2, 3, 4, 5, you know, if this is character number 5 in the word square, this should be character number 6 in the word formation. So it's really important to keep track of both the horizontal offset and the vertical offset. Now, when we're doing down here, this is where things really get sloppy, and I'm sorry about this. Ugh. Anyway, the point is, so what are we looking at here? In fact, here. This line is too long. It's too big. Okay, there we go. So that's a little more manageable, I'd say. Okay, great. So what are we doing with this? First of all, we've got intersection 1, intersection 2, intersection 3, and intersection 4. What are these? Well, basically, I guess this isn't really great, the wording of it, calling these intersection 1 and all that. What we're trying to check is basically like the part of this word and this word over here. So like, okay, as we're going through these and we're looking at different like Q and P values, maybe what we'll be looking at is we'll look at R and S, then we'll look at M and Q, then we'll look at A and U, and we want to keep doing that. And we also, at the same time, using the horizontal offset, we're going to be looking at the something. So we're going to say S and M, and then O and E, and then M and T. And we're going to keep that going until we find a pair that match up, right? So like, for example, I'm trying to find a good example. I'm actually trying to find the example that's making this not work because it's because of what we're doing here. There's an element of what we're doing that's making this not work. Now, while I look for that, another thing I want to mention is you notice these intersection 2, intersection 4. We have these listed just if these, are. Basically, what we're trying to check is, are they undefined? Because they might be undefined. Keep in mind, these are coming from like h word 2 at p plus h offset and v word 2 at q plus v offset. So h offset and v offset can both be positive or negative. They might extend beyond the indices of the word. They might be something less than 0. They might be something greater than the word's length. So because of that, they might both be undefined, in which case I think this one would actually return true. It would say, oh, okay, yeah, that's fine. They're both undefined. So we do need to check if they, actually exist, sort of thing. Okay, cool. So if all that matches up, and like, okay, just to use this as an example, right? We have E and I as like a combination of letters that we can use here. So for the E and I, that matches up with the other E and I in these words here. And that's actually what we're seeing in terms of the console log, because I'm console logging the 4 intersections and the p-value for some reason. But anyway, I don't think we need that. Actually, wait. Hold on a sec. Because the last time we were here, we broke the function. And I'm about to explain how we broke it. First of all, hopefully this is clear. Hopefully this is making sense so far in terms of like, when we're doing a formations plus the situation. And by the way, formations is just this variable. It's allowing us to count how many ways we can do a formation here. So we're just going through all the possibilities, brute force, super brute force wise. And as soon as we find one that works, we're saying, okay, formations plus. The other thing is we noticed from the problem description yesterday that each of these is kind of like a reflection, right? If we were to take a diagonal line like this and reflect along this line, then what we'd find is that this would become this, right? So we'd have crossword and something, instead of going horizontally, they would be going vertically. We'd have formation and square, instead of going vertically, they would be going horizontally. All of the same intersection points and all that. So basically the idea is that since we can just reflect each of these to get another one here, I'm doubling it. I'm multiplying formations by 2 because of the reflection thing. So I figured if we do it that way, then there's less to consider. Okay, so basically, yeah, I mean, there is a VOD for all this. You can go through it if you need to rewatch it. But to be honest, I think we're going to be redoing quite a bit of this. We'll find out. But anyway, before we go any further, I want to fix this, okay? Because there's this thing up top that's kind of weird. So basically, this is calling do crossword, which is this thing down here. And then we're also calling it with a different orientation. So we're basically just rearranging the words here. In case you're wondering about this map thing over here, I'm just saying take the indices 0, 1, 3, and 2 and map each of those to the corresponding entries of the array words. Okay, and then we're using that as the arguments for our do crossword function, which is basically just giving us the number of ways we can form a formation with that orientation of words. So what I was doing after is I was trying to add a little more onto this, and I was saying, okay, well, if we're considering considering all the possibilities up to a reflection, then what needs to change? So basically crossword will stay the same. The only other thing that really needs to change is, since we know that these two vertical words can go in either order, we just need to sort of swap out the last word, which one is going to be the horizontal word. So basically we start with it being the one at index 3, and then we're doing this, we're sort of swapping it with the one at index 2, so that it's the one at index 2, and then finally we can put the one at index 1 there. So we'll just do, I guess what am I missing here? 2. Yeah, there we go. Sorry about that. Anyway, so if we do this, this should actually be giving us all the possibilities, all the permutations that we could possibly ask for. So let's try running the tests on that and let's see if that fixes our issue. Well, no, actually it doesn't. In fact, it makes it worse. So now we're only passing 1 out of 6 tests, which is really not what we want to be doing, right? Because we just tried to fix a problem and now we're actually getting more problems as a result. So, okay, let's take a look at what's going on here. Well, it's saying in that final orientation, so I guess this would be a one where we have 0 and 1. So we'd have crossword, crossword, and then the other horizontal one would be something, I guess. So it would be this over here. And it's saying that one of the possibilities is RS and RS. How's that working? Because something doesn't have an R in it. So that's kind of weird, right? Oh, maybe it's crossword. Wait, no, yeah, crossword is that one. Okay, my mistake. Is there one with an R and an S? I guess technically square, but yeah, it's kind of curious how it's getting those R's and S's. We probably shouldn't be getting those because I would think that we're sort of getting those originally over here. The point is, I don't know exactly where it's happening, but there's an overlap happening. It's either an overlap or it's something that's happening too close. Because basically what we have going on here is, you remember how we had to do this, you know, like checking to see if these two vertical words were too close, just to make sure that, like, you know, the box in the middle, it doesn't have an area of 0. So we're doing this to check if these two words are too close, but we're not actually doing anything to check if the two horizontal words are too close. So we should probably do that. Specifically, what we need to do in order to do that is, I guess we'll just, for now, we can just throw it in here just because, you know, we're not too worried with the efficiency of this. We can always clean it up if we need to. But we need to do something like this. So math.abs of, I guess it's Q and K. We need to make sure that this is greater than 1, and then all the rest of this stuff as well. So, whoa, what's going on with that? Huh. Okay, anyway, I should probably put this on the, yeah, okay, that's better. Cool. Is it Q and K? Let me just verify that. So yeah, Q is the V word 1 position that we're connecting the second horizontal word to, and K is the other V word 1 position. Yeah, okay, cool. So let's try this. Let's try running the test on this, and that feels better. So we probably don't need the console log anymore. Let's clean that up a little bit. Yeah, thanks, Rainbow. I spotted him. Okay, so we'll run that. Cool. All right, that's good. Yeah, nice. But does it pass all the hidden tests? Something tells me it might not. I just think it might time out on one of these, considering how inefficient it is. Oh, wait. Hold on a minute. I'm getting mixed signals here. So, all right, it's saying great work. You've solved crossword formation. We're getting the 300 coins. That's nice. We'll close this. Oh, hey, level complete. Well, that's extra nice. 6,000. Yeah, that's pretty tasty. All right, let's close it. And wow, just to top it all off. Well, thanks. Okay, great. What? Okay, folks, I need to screenshot this. I've never seen anything like that before. Let me paste that into Paint. Okay, cool. That's, wow, that's new. Okay, so, maybe there's like some other test that's like an unofficial test that's being run here or something like that. I've really never seen anything like that. Let me try doing Control Enter again and we'll see what it says. Especially because it says it's, oh, all right. Okay, well that's pretty interesting. Something new. Anyway, let's go back to our description over here. Okay, I'm gonna make some changes here. I'm glad we have something that's working, but it's heinously ugly, and I think it could be a lot more efficient. I mean, even just like our variable names are pretty dreadful at this point. So if I'm being real with you guys, I kind of want to forget this ever happened. So let's see. I guess here we'll do a good old Control X. We'll confirm this. I'm gonna do like a billion enters, and I'm gonna rename both of these because we're probably gonna do something similar for this next one. So, this feels better. All right, our screen isn't full of ugly garbage yet, so let's get that done. So basically, what we want to do here is we want to do something similar to what we had before. We want to call do crossword with words, or actually with the spread it out version of words, right? Not just words, but like, yeah, like this. The brackets? Oh, do you mean these ones, Rainbow? This this big old wave right here? Yeah, it's a bit intimidating. I can't promise you that this is going to be any better in that regard. It's I actually am not really sure if there's a way around it in this problem. If there is, then yeah, hopefully we'll figure it out. But yeah, as for now, we'll see. So what do we want to be doing with this? We want a horizontal word. We want a vertical. Well, okay, we want 2 horizontal words, 2 vertical words. What would be the best order to put these in? I guess it doesn't really matter. Okay, so like H word 1, H word 2, V word 1, V word 2. Okay, we'll just do that. Yeah, just to sort of put them in this kind of arbitrary order, and then we'll switch them up after that. Okay, so let's go back to the drawing board for a minute here. So actually, maybe this was a mistake. This is not looking ideal. Let's get out of the drawing board for a minute here. Okay, so let's think about this, okay, in terms of how we want to do this. So we're going to set up our horizontal word, and it's just going to be doing its thing. I haven't decided yet if we're actually going to consider all of the possibilities, all the permutations, because we're going to have to consider a lot more of them, right? Because in this case over here, we were basically saying, well, it doesn't really matter which one's the first vertical word or which one's the second one. They could go in either order. It doesn't really matter. So because of that, we didn't need to consider as many possibilities over here. But now we are going to actually order them. So we're going to say, yeah, this one is definitely above this one, and this one is definitely to the left of this one. So that's going to be sort of the idea behind this one. Because of that, we're going to have to consider a lot more of these possibilities. So, you know, this part of the function is going to look a lot longer. So with that in mind, since we're going to have to consider a lot more permutations anyway, I'm thinking, you know, I don't know if we're gonna like bother with the formations times 2 thing, or if we're just gonna run through all the possible permutations. It might be more efficient to do it that way, not in terms of complexity necessarily, but in terms of, you know, the way it's gonna look, the way it's all gonna be structured. So we'll find out. And by the way, just for anyone who's watching, I should mention, we're not going to be totally done with this today. We're going to make some progress, but there's something we're going to do tomorrow that's going to sort of wrap things up a little bit. And it's the thing that I'm actually really looking forward to, because this is a bit of a spoiler alert, but we're going to be using something tomorrow that I've never done before. So it's stepping outside my comfort zone. We're going to be looking at something that's totally new to me. It might not be totally new to you guys, so if you're aware of it, I'll look forward to receiving your help, but it's totally new to me, so it's going to be a learning experience. We'll see how it goes. As for now, let's continue with this learning experience. So basically the idea is that we have horizontal word 1, horizontal word 2, vertical word 1, vertical word 2. We're going to sort of use horizontal word 1 as like, you know, our canvas here, so to speak. It's like our blank slate that we're looking at. So we need to be, well, okay, before we go any further, let's just do this, same as what we had before. So we're going to have some number of formations. And I think I'm just going to do it this way, where we just return formations at this point. Okay, so basically we've got that. Now we want to loop through our first horizontal word. So we're going to say I is less than H word 1 dot length and I plus plus. But hold on. What are we actually doing with this? This is going to be for, I guess, V word 1, right? Like the connection point of V word 1. You know, is it going to be the C? Is it going to be the R? Is it going to be the O, etc., right? So since this loop is basically for V word 1, let's consider the limitations on V word 1. Well, the furthest right it could possibly be, my claim is basically this right here. Why am I saying this? Well, basically because the furthest right that V word 2 could be, square, would be over here, right? I mean, obviously it's not going to fit in this particular case, but it couldn't go any further right than this. Otherwise, it won't be actually forming 4 pairwise connections. You know, it would be missing this word, which it can't do. So basically the idea is that this and this corresponding spot, this is basically the furthest right that vword2 could possibly be. And we know that vword1 can't overlap vword2. And let me make this a little more visual. So this over here is vword2, okay? So if this is vword2, and this is the most extreme case, that means that we can't have anything right next to it, right? Because then the intersection would be like, there'd be a 0 area for the empty rectangle in the middle. So it can't be over there, and it definitely can't be on top of this one, which means that the next possibility that we have for, or the rightmost possibility we have for vword1 is going to be this right here. Woo, okay. Jeez, I'm having a hard time. I guess this 1 and this 2 look almost identical, so sorry about that. But anyway, the main thing I'm trying to say is that instead of going all the way to hword1.length, I'm going to make it go to hword1.length minus 2, okay? Because we know it can't go any further than that. All right, now let's try to find how long our next one can go, right? So like this is for vword1, right? So we want to find out vword2. Where can it go? Well, we know it can go all the way to the end. We just talked about that for a while. But where could it start? It wouldn't be able to take this position because, that's the last possible position of the first one, formation, and it wouldn't be able to take this position. So we could say something like this: for let j be assigned the value of 2, and j is less than hword1.length, going all the way to the end there, and then j++. Here's the thing, though. We can do a bit better than this, because not only are we trying to say that this thing over here, not only are we trying to say that vword2, sorry, there's a lot to keep track of here, but not only are we trying to say that vword2 can't go as far as like this position or this position, really what we're trying to say is it can't even go as far as this position in this particular case. If vword1 is over here, vword2 can't even be right next to it. It has to be at least 2 over. So in the extreme case, vword1 would be starting at 0, but we actually know where it's starting. So instead of just 2, we might as well say I plus 2. Okay, so basically, yeah. Rainbow Sprinkles knows what's up. Nice job. So yeah, exactly. That's what we want to do. So there we go. This is basically finding our connection points here for our 2 vertical words. That's basically the idea. Okay, so what should we do from here? I guess we could do something like for we're gonna run out of letters here. K and L, I guess. For let K be assigned the value of 0, and K is less than vword1.length. Okay, now the question again is, are we gonna go all the way to the end here? And the answer is no. If we're checking formation here and we're trying to see how it connects with the word crossword, then basically the idea is that there's no sense in checking the O or the N when comparing it to crossword, because even if it does connect with the O, there's no room for another word to connect there. So we're going to put a -2 on that one as well. And you know what? Now that I'm thinking about it, I'm kind of thinking this might be better at a higher level. It might not be. I actually don't know which is better, but I'm just thinking maybe we should switch it. Because here, this is like starting with just 2 words. It's like starting with just crossword and formation. I think this is kind of nice. And we can basically just say like, if, what do we want to check here? So if vword1, okay, if hword1, just to put it in order, at I is the same as vword1 at J, at K, yeah, then we'll continue. Otherwise, we won't. So this is bad news for our guy Rainbow Sprinkles, who did not want to see more levels of nesting here, but hey, I might actually have a bit of a fix for that. But not yet, so we'll continue with this. Okay, so it's basically saying, all right, hey, we found one that works. We found a connection point for crossword and formation. The first one it would find is yeah, probably this one right here at the R. The next one would probably be this O with this O, just like over here, right? But it's found this one. We basically want to say from there, well, okay, cool. Let's get another vertical word there. It's going to start right here because we know that formation connected there. Okay, so this one's going to start here. Yeah, it would find a connection with the S right here, S for square. It would then move on to this one, then eventually would find this one because there's also an R in square. So we basically want to say as soon as we find this, and only as soon as we find this, do we want to activate the rest of it. So after that point, we say, oh, okay, well, you might as well keep looking. So we're going to go to square from there. We're going to load up our V word 2 and see what happens with that. So that's why we want to run through our H word 1 again. And specifically, we're starting it after our V word 1. In fact, not just 1 unit, but 2 units after. Okay, so what are we up to? L. L is going to start at, I guess, 0, and it's going to go all the way to V word 2 dot length, and again, -2, because we need to make sure that there's some room at the bottom, right? We need to make sure, like, no sense in checking the R or the E, because then we wouldn't have any room for another word to fit below it, okay? So that's why we're putting the -2 on this one. All right, so what do we want to check over here? Basically, we want to check if H word 1 at J is equal to V word 2 at L. Yeah, okay, cool. If that's the case, well, hey, we've got a nice setup here. You know, at this point, we basically have crossword and formation connected, and we have crossword and square connected. And we know that we have them connected in such a way that spaces them out appropriately, and it leaves room for another word at the bottom to be spaced out appropriately. So that's good. That's good stuff. Okay, cool. So we've got this if over here. So once we've reached this point, we know something for sure. Okay, we have 3 connected words. Just need to see if the if H word 2 can fit in. Okay, cool. Yeah, that's all we need to do. So how are we going to do that? Well, again, consulting what we had down here, remember, even when we got to that point, there are 2 sort of degrees of freedom here, because the something could be moved left or right, and it could also be moved up or down. So we're going to have to sort of refine this a little bit. So here's what we'll say. Geez, messy down there. Okay. We need 2 other for loops. Okay, we're going to have another for loop here. We're going to have another for loop here. And at this point, once we get inside here, we'll do our final if. And if it's true, if it's good, we'll do a formations plus plus. Okay. Yeah. Okay, cool. So what are we going to do with this? I guess P and Q, right? I think we used P and Q downstairs. Yeah, I think so. You know what? We could probably calculate our offsets like what we had before. So we could say like const H offset and V offset. Yeah, let's get those in here. I missed them. Okay, what are they going to be? So H offset is going to be basically this index of H word 1 minus this index of H word 1. We don't need to do any math.abs kind of business or anything like that. We don't need to worry about there being a negative number or anything like that. This is going to be nice and easy. Okay, so basically we'll say, what are the indices? Is it I and J? Yeah, I and J. Okay, so it's going to be just J minus I. And we know, actually, not only is that going to be non-negative, it's going to be positive. Because, yeah, like it has to be 2 at least. In fact, I'm pretty sure, right? Because of the way these are spaced out. All right, and then V offset. That actually, this I guess could be positive or negative. Yeah, the horizontal offset has to be positive because we know that like this word must come after this word. But that's not necessarily true of the V offset. The V offset, we know that like for both of these, we're not going all the way to the end of the word, but we don't know which one is going to be like higher up or anything like that. So this one might be positive, might be negative. We'll still have to check to see if that part of the word exists, right? Like if the word has a letter at that index. Yeah, so we'll see. Anyway, So we've got this. What is the V offset? I guess it's going to be something like L minus K. Does that make sense? Yeah, I think it's going to be L minus K. And I think these are probably pretty similar to what we had down here. J minus I, L minus K. Yeah, they're the same. Okay, cool. So that's nice. We've got our offsets over here. So what are we going to do with this? All right. Well, basically, we need to cover two more things, right? One of these is going to go through something. Right? So it's going to say for let, yeah, we'll use P and Q. So P will be the one that goes through the word something. It's going to start at 0, and specifically P is going to refer to the index in the word something where V word 1 connects. Okay? So, and I should call this H word 2 and not something, but oh well. So basically it's specifically where something and formation would intersect over here, or where, you know, square and formation would intersect in this one. So, you know, it's specifically this one and not this one, the E here. That's why I'm mentioning it. Okay, so basically P starts at 0. P is going to go all the way to H word 2 dot length. But actually not all the way, because keep in mind, it, like, no sense in checking these two over here, right? We don't need to check these because it's never going to go that far. Like, this connection point here couldn't be this or this because it wouldn't leave enough room for V word 2 to connect to the word. So at least we're going to be subtracting 2 from it. But it's actually more than just that. So basically the idea is that 2 is basically the minimum H offset that we have, but we might have a much greater H offset, so we'll put that in. Okay, and we'll see you later, Rainbow. Thanks for stopping by, my man. Let me know if you have any questions when you're rewatching it or anything like that. And I hopefully see you tomorrow, where we'll try to finish this up. Okay, cool. So continuing with this, what have we got? Yeah, okay, so we've got P, the connection point, in H word 2. Now, our final thing here, we need to see where H word 2 is going to connect up here. So I'm going to start it at this letter right here. This was basically the location of V word 1 that connected to this, to H word 1, plus 2. Okay, so we're taking this connection point and then we're adding 2 to it, because it couldn't be this close. It certainly couldn't overlap it, and it definitely wouldn't be above, because we know it's H word 2, not H word 1. So we're going to start over here. So what was the index in V word 1 that we were using? It was K, right? So whatever K ends up being, and it might be 0, it might be all the way up to V word 1 dot length minus 2, or minus 3 technically. Anyway, the point is, so that's K, right? So we're going to start this at K plus 2, okay? Because K would be the index of formation here, so it would be 2 in this case. So we want to start at 4. So it's going to be K plus 2. So we're going to say let Q be assigned the value of K plus 2. And we're going to keep this going until Q gets to the end of V word 1. Yeah, Q plus plus. We could refine this over here. In fact, that's probably a smart thing to do. We're not going to do it quite yet, but it's probably a good idea. So, all right, we've got this. Okay, teachable moment here. Do not let this happen to you. I need to make sure I didn't do that anywhere else. That's one of those things when you're going through an array and you forget the dot length. That's one of those things that's like, wait, what? Why is this not working? That can be really baffling, really perplexing. So, hey, I'm glad it happened. Don't let it happen to you. Okay, so let's continue this. So basically, what do we want to check here? At this point, we know the following. We know that the first horizontal word has been connected to the other vertical words. We know that we have our last word over here. We know it's going to be somewhere beneath this one. We know that it's going to be arranged in such a way that it can connect to both of these words, at least horizontally. What we don't know yet is, you know, because I'm saying it can go, I'm saying Q can go all the way to the bottom here, but really that's not actually true, because in this case over here, it wouldn't be actually connecting with the word square. So we do sort of need to check that. So what we need to check is, first of all, that V word 2 at Q plus V offset exists. We need to make sure of that. Okay, so If it doesn't exist, it'll be like undefined or something. It'll be typecast to false. So it's okay to just put this in here. You know, we don't need to say like dot exists or something like that. We don't need anything like that. This is fine. What else do we need to make sure of? Well, we need to make sure that this is actually doing the thing we want it to do. What is that? Well, we need to make sure that basically the words connect up, right? Yeah, just like we did over here. So we found one connection point, which was the R in this case. We found another connection point, which was the S in this case. Now we need to find two others. So basically we need to make sure that H word 2 at something is going to be equal to V word 1 at something. And we also need to make sure that H word 2 at something is going to be the same as V word 2 at something. Okay, let's talk about what these somethings are. Okay, so first of all, H word 2, we're keeping track of this P iterator over here, and that represents the point where it should connect up with V word 1. But where is V word 1 connecting up? Well, that's actually what Q is for, right? It's showing us the location in V word 1 where it makes this connection. So we'll put the Q in there. Now this is where things get a little more complicated, but basically H word 2 at P plus H offset, and we know that one's going to work. Notice we didn't have to check if this actually exists because we designed it that way. We have like the minus H offset here thing to make sure that this won't go beyond the range of values that that the word would accommodate. So basically over here, this is where we'll put our Q plus V offset. Okay, so we'll put that in there, and now we'll close that up. We're returning formations. At this point, maybe I'll just close the gap here, and should we give it a run? I don't know, I'm kind of curious. Maybe we don't need all those spaces there, but let's give this a run. And okay, surprisingly, it's passing one of them. Okay, that's probably by fluke, but anyway. What are we getting for this one? We're getting 1. Okay. Okay. Well, this is great. I love this because we're basically saying we've got crossword and square, we've got formation and something. So in this particular case, we're saying crossword and square are going to be the horizontal words, just like this here and this here. And we're saying formation and something are going to be the vertical words in that order, right? So it's going to be crossword and then square. And then it's going to be formation, and to the right of that, something. Okay. Now let's take a look at what we've got over here. Something to notice is that there was only one of these that had the words in that order, which makes sense that there would only be one of these at the end of it. So, okay, that's pretty good. So if we wanted to do this, if we want to actually get all of our possible answers here, we'd probably have to do something like this, you know, plus do crossword with something else, right? So dot, 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 and then we'll do this dot map. Yeah, this is basically how we had it before. I think I can use an I in here, and it's going to map to words at I. Is there a better way to do that aside from using a dot map? I don't know. I have a feeling there is, but I can't seem to remember what it is. Anyway, so by default, what we had up top there is basically this. Like if we tried to run this, then it would give us like 2 in this case because it's just running this twice. It's just adding it to itself, right? So let's not do that, but we'll be inspired by that. It's going to be the idea. Okay, so I'm going to copy this, and then I'm going to paste this in a whole bunch of times. How many times? So how many permutations will we have? It's something like 24, right? Because it's like 4 factorial, I think it would be, because we have 4 elements, 4 factorial. So, all right, 20 more pastes. Let's do it. Great. All right, so let's start with all the ones that have 0 as a first element. Yeah, okay. So we've got this one. We've got 0, 1, 2, 3. Well, first thing we could do is switch the 3 and the 2. Okay, great. We're not going to find any other possibilities that begin with 0 and 1, so we're going to bump this one up to a 2. So if that's a 2, we could have 1 and 3. If that's a 2, we could have 3 and 1. Right? Okay, cool. What other possibilities? Well, I guess this could be a 3, in which case we could have 1 and 2, or we have 2 and 1. All right, that's all the possibilities that start with a 0. You can see that this is a pretty tedious way to do this stuff. So ultimately, we want to be finding some kind of alternative so that we don't have to run through this every time, because it's kind of inconvenient. So what could we do then? Well, that's going to be for next time, actually. After we finish this, just listing out all the permutations manually, which, yeah, it's no picnic. After we finish this, basically, we're going to talk about ways that we could actually generate these programmatically. Because, hey, someone's probably done that already, right? I mean, this doesn't seem like the most obscure problem in the world, doesn't seem like the most obscure thing to want to do, like just finding permutations and stuff. Yeah, probably people have done that already. In fact, they have. So basically, we'll soon look at some of those ways. I think that's half of them, right? Have we reached the halfway point? Oof, I feel like I've accomplished something. Okay, so let's make these all 2s for a little bit. There should be 6 of them, right? Let's make these all 3s. Whoops, how'd that get in there? There's no such thing as 4. Okay, cool. So let's go back to the 2s. Yeah, because these are all kind of wrong now. So 2, 0, 2, 0. We could have the 1s. We could have the 3s. Oh, this is kind of a neat way to do it. Yeah, I like this better. Okay, we could have 3, 0. We could have 3, 1. Or we could have 3, 2. Okay, great. And then over here, we could have 1, 3, or we could have 3, 1. For this one, it could be 0, 3, or 3, 0. For these ones, what do we have? 0 and 1, or 1 and 0? Yeah. Yeah, so basically, there are lots of ways to do this. I mean, I'm not really following any particular algorithm going through these manually. But yeah, there are algorithms that could be used. We're going to talk a lot about them tomorrow, or at least a bit about them tomorrow. That's the plan. I think the most popular one is called Heaps Algorithm. I've heard that. Correct me if I'm wrong, I guess, but I think that's the most popular one. It seems to be used quite a bit. How do we get a 3 in there? That should have been a 2, and then that's a 0. Okay, cool. So I think that's all of them. This should work, I think. Let's find out. Let's try running that. Oh, great. That works. Okay, this part here, the do crossword, I realize there's a lot of nesting in here, but this feels a lot cleaner than this stuff down here. I really want to forget this even existed. Please don't look at this. It's bad. Okay, cool. So, yeah. Basically, let's I guess let's see if it passes the hidden test. I think it probably should, especially if the other one did, because this one's going to run a lot more efficiently. So great. Nice stuff. Now, what I was kind of saying before is we could probably cut down on like half of these, delete half of them if we were to just rearrange, just say like, just corresponding to like the reflections we were talking about before, if we were to just put a ×2 at the end of this, or even like at the beginning of this, right? Return 2 times all this stuff. We could take advantage of the symmetry embedded within this problem, but I mean, I figure if we could make an algorithm to just generate all of these permutations, in some ways I feel like that's going to be a little more elegant. I feel like probably the best way to do it would be to not repeat ourselves, right? So to not do calculations that we know we don't have to, right? So that's kind of what I'm getting at with these. If we know this one works, then we can guarantee that this one is going to work as well. There will never be an odd number in terms of our solutions here. Our outputs will always be even numbers in this case. So yeah, probably the most elegant thing to do would be to generate an algorithm that's going to produce these permutations, but only half of them. It's going to say, oh, well, that's just like a reflection of this other one, so we don't need to bother with that one. That's probably the best thing we could do, but to be honest, I don't even know if we're going to get to that tomorrow, so it would be nice. But anyway, if we look at this, it's working. It's still pretty brute forcey. That's the thing. Like, we're not really using any algorithmic data structure based like tricks or anything like that. So yeah, it's still pretty brute force. So I don't know if I love it, but I like it a lot better. Especially this part down here. I like it a lot better than what we had before. Yeah, it's nice. And this part, we'll make it better tomorrow. So, I mean, I guess just to give you guys a taste, we're probably going to use something like this. Okay, so this is Heaps Algorithm. There's this cool little image here. I guess I can't zoom in that much here unless, no, that's not really helping. Okay, so basically, this is kind of showing us what Heaps Algorithm is doing. It's kind of neat, you know, just tracing these around. It's not really easy to see the pattern right off the bat, but we'll talk about it. It's like, one of those things, like DNAs, you know, it's like a really messed up DNA strand. Anyway, what you're probably learning right now is I know nothing about biology. So that's for the best. You guys don't come here for biology knowledge. We're here to talk about programming and math. All right, anyway, for now, I guess I'll say goodbye. I'll talk to you guys later. We're gonna end the stream there. And we'll continue with this stuff tomorrow. I realize we are kind of, you know, technically done with the labyrinth of nested loops, but I really want to crush it. You know, I really want to produce something that I think we can be proud of. So we're not going to move on to the book market quite yet.